The objective of this lesson is to solve mixed number subtraction problems, including those that require decomposition. In previous lessons, students learned strategies for solving mixed number subtraction problems that required decomposition. Today, they will continue to practice different strategies in order to solve problems involving subtraction with mixed numbers, where the subtrahend and minuend will both need decomposition. Let's begin with our first problem. Maxwell lives 3 1/5 miles away from the soccer field. After practice, he started walking home. He walked 1 3/5 miles before his dad picked him up and drove him the rest of the way home. How far was the car ride? The equation to represent this problem situation is the 3 1/5 miles total to get home minus the 1 3/5 mile he had already walked equals d, the distance left to travel in the car to get home. Let's model this equation using rectangles. Draw 4 long rectangles. Shade in 3 rectangles for the 3 holes. Divide the last rectangle into fifths and shade in 1 piece for the 1/5 fractional piece started with. Decompose the minuend and subtrahend into wholes and fractional pieces. The equation will now read 3 plus 1/5 minus 1 plus 3/5 equals d. Subtract the fractional pieces first. 1/5 minus 3/5. The 3/5 in the subtrahend is a larger fractional piece than the 1/5 in the minuend. In order to solve, the minuend needs to be decomposed. There are multiple ways to decompose this problem in order to solve. Let's decompose just one of the wholes in the minuend into fifths. Take one of the wholes and divide it into fifths. There are 5 fifths in one whole. The equation now reads 2 wholes plus 5 fifths plus 1/5 minus 1 whole plus 3/5 equals d, the distance left to go. Let's add all the fractional pieces in the minuend together. There are 5 fifths in the decomposed 1 whole, plus the 1/5 fractional piece, for a total of 6 fifths. The equation will now read 2 wholes plus 6 fifths minus 1 whole plus 3/5 equals d. If we place the wholes together and the fractional pieces together, we can subtract the 3/5 from the 6 fifths and the 1 whole from the 2 wholes. The equation will read 2 minus 1 plus 6 fifths minus 3/5 equals d. Maxwell had 1 3/5 miles to drive in the car. Let's solve the same problem, but this time using the strategy of rounding the subtrahend and then compensating. To represent this on the number line, label the number line from 0 to 4, since 3 1/5 miles is just more than 3 but less than 4. Now divide each whole into fifths in order to include the 1/5 fractional piece. The 3 1/5 mile mark is just 1 notch or 1/5 past the 3. The next step is to subtract the 1 3/5. Because the subtrahend fractional piece is larger than the minuend fractional piece, the 3/5 cannot just be taken from the 1/5. So let's round the 1 3/5 to 2 wholes because it is easier to subtract a whole than a fraction. Subtract the rounded minuend of 2 from the subtrahend of 3 1/5. This is modeled on the number line by moving back 2 wholes to the 1 1/5 mark. The difference is 1 1/5. Initially, the subtrahend was only 1 3/5. It was rounded to 2 wholes, which is 2/5 more than the initial subtrahend. In order to compensate for the rounding, 2/5 must be added to the difference of 1 1/5. On the number line, this is modeled by starting at the 1 1/5 mark and moving up or adding 2 fifths. The total distance left to go is 1 3/5 miles. There are many strategies to solve mixed number subtraction problems. Some strategies will make more sense to students than others. They are not required to master all the strategies and should be encouraged to use the strategy they are most comfortable with. However, learning 2 strategies can help students know if they got the correct answer. The objective for this lesson was to solve mixed number subtraction problems, including those that require decomposition. We met this objective by solving a real-world problem visually and numerically by decomposing the minuend and septuagint in order to subtract distances. We also solved the same problem using the strategy of rounding the septuagint and then compensating.